We know math. We're pretty decent at it, or we faked our way through college to pass those classes. But how? But how do I take this type of information? How do we take it? And how do we break it down so that way it's, I don't want to say acceptable, but to the point where as you guys understand the concepts and can continue with them. Yes, ma'am. No, this is more of I had to switch. I'm going to switch some stuff up. I hadn't get a chance to adjust the calendars yet. This is going to be parts of 2, 4 through 5. We're kind of molding a whole bunch of junk together today. 2, 3 was kind of what we already did. I get my mix up from the new text though. So there's 2 laws that we're going to talk about. One of them is called the law of detachment. And basically the law of detachment is if the hypothesis of a true conditional statement is true, the conclusion is also true. But in other words, don't write that down. Law of detachment. Oops. Wrong button. Hold on. I want you to see this. Really, really, really simple thing. If I'm all right. If Moose eats a pizza, he will that's right. No, that's funny. I knew you were going to go with the give the moose a cookie. Yeah. As soon as I said that, I heard you say he will want a cup of milk. Yeah. He will have a Sprite. All right, I'll make this up. Moose ate a pizza. What can you say? Drink Sprite. That's literally what it is. Law of detachment sounds very, very choppy. I see where you're going with that. If Moose eats a pizza, he will have a Sprite. Moose ate a pizza. Moose had Sprite. Right? It's the idea behind what's called this law of detachment is that you get a conditional statement, an if-then statement. After that statement, they say the first part, the if portion, is true. I didn't want to write out the actual definition. The definition sucks. Because this is an example. Because the difference between that, this detachment idea, versus what's called syllogism, or transitive property, if you will, it is so, they're so different from one another, it's very, very easy to decide which one you're using, just because of the way that they sound. Again, if Moose eats a pizza, he will then have a Sprite. Moose ate a pizza. Conclusion then is, he had a Sprite. That's what detachment looks like. You've got an if-then. They tell you the if part was true, which therefore means the then part has to be true. So you want to think of it of an easier way of a definition. When we use if-then, our first one was our conditional statement. You guys remember that from yesterday? That was P implies Q. So an idea here would be P implies Q. Oops, sorry. P is true. Therefore, Q is true. That's kind of what this means. It's very choppy. It's very choppy. Moose eats a pizza, then he'll have a Sprite. Moose ate a pizza, he had a Sprite. It takes that conditional statement and breaks it into just two separate sentences. Okay. That's pseudo makes sense? Okay. Excuse me. The other one is different. The other one is so easy to work with, right? It's so simple. It's called the law of syllogism. I can't spell that. I don't even know how to try it. We'll just do this. Law of syllogism. Again, I don't want to use the word definition because the word definition is awful. But if I show you an example of what it looks like, you're going to go, oh, that's easy. And I would say, yeah, no. That's kind of how it goes. All right. You ready? Syllogism. Syllogism. Steve is older than Ken. Ken is older than Betty. Steve is older than Betty. Steve's older than Ken. Ken's older than Betty. Steve's older than Betty. You see what I'm saying? See how this goes? See how quick? I'm just making a quick example. Steve's older than Ken. Ken's older than Betty. Therefore, Steve has to be older than Betty. The idea here is that this idea of syllogism, it's very smooth. It flows cleaner. Moose eats a pizza. If Moose eats a pizza, he has a Sprite. Moose ate a pizza, he had a Sprite. Steve's taller than Ken. Ken's taller than Betty. Steve's taller than Betty. It's smoother. It's a nicer, easier way to transition through the logic. Any of you guys ever played the game Clue? You know, it's kind of that you're using reasoning as you go through that game to come up with a conclusion. So and so did this, so and so did that, and you kind of figure your way through it. Okay? That game's a mixture of syllogism and detachment because it kind of what you have. Okay? That's where the stuff comes from. So this idea of this law of syllogism, the easy way to look at it, A equals B, B equals C. What can I say? A equals C. Very good. Because what happens here, to be able to tell the difference, the second thing you say in your first statement is the first thing you say in your second statement. It's repeated. It's repeated. That's why this syllogism step works. It's also known as, in algebra, it's known as what's called the transitive property. 7's bigger than 4, 4's bigger than 2, 7's bigger than 2. You guys have all done that before. You just didn't realize that that's exactly what you were doing. Does that ring a bell when you were first learning about place value and stuff? Oh. I've seen it on my kids' homework. I know that's been taught. I know it's been gone through. Again, this idea of the syllogism, it's a very smooth way of going it versus detachment, where it sounds a little bit more choppy. Show you. Where was it? No, I'll do that. I skipped it. Where's my thing? That my PDF didn't show. Sorry about that, guys. Save the wrong file. Oh, here we go. Let's read this. A lot of these things is tough to write out completely, so I just want to kind of read through it with you guys, and you can tell me whether or not it's syllogism or detachment. If an angle measures more than 90, then it is not acute. Angle ABC is equal to 120. Angle ABC is not acute. Detachment or syllogism? It's detachment, isn't it? It doesn't have that repetitiveness like syllogism does. Is the first part of the statement true? Yeah, ABC is greater than 90. Therefore, the second part has to be true. ABC is not acute. That's how that works. It's super quick as you go through it. Right? Super quick. Oops. Close out these. Read again. If you order the apple pie, then it will be served with ice cream. Matthew ordered apple pie. Matthew was served ice cream. Detachment or syllogism? Detachment. That's detachment again, isn't it? Yeah. Remember, if it's going to be syllogism, then the second statement would say if he was served ice cream, and so on. See where I'm going? Because if you read the next one, if you wear school colors, then you have school spirit. If you have school spirit, then your team feels great. If you wear school colors, then your team feels great. That's the syllogism. See how it's repeated through? It's repeated on that diagonal. Right. It's the repetitiveness across it. That's where that comes through. So this is your syllogism because these two have been repeated on that diagonal. Okay? That's where the first and the last part just drop together. Oops. Yeah, we're okay. So the idea behind doing these things, right, this detachment, this syllogism, it's going to eventually allow us to get into what are called proofs. As we get towards this scary five-letter word of proof, it's not meant to be daunting. It's not meant to be overwhelming. It's the idea that you can put a string of logic together, understanding what this looks like versus what some properties are. So what I wanted to look at also today, along with this, was the start of this idea of what is a two-column proof? So let me show you guys what a two-column proof, how it sets up. We're not doing any geometry with it yet. We're going to start doing this stuff with some equations, solve for x stuff. We're going to write down what we're doing. In geometry, we use these things that are called proofs. And one of the most common one that we use is called a two-column proof. A two-column proof has, well, two columns. I know, right? One has your what are called statements, and the other side are your reasons. And basically that stands for what you are doing and the reasons are why. More often than not, your reasons are definitions and theorems. The reasons will be definitions and theorems. Your statements are going to be broken up chunks of those definitions and theorems. What I like to do with you guys is start with the algebra show you how you all know how to solve a two-step equation, or hope, and then how do you work with them into a proof. Because as we get going into next week, and I know we have a little bit of a choppy week, we're going to start talking about the idea of what's called congruency. How do we put together a reason bank? How do we use what's called a progression? But it all starts with when you put together your thoughts on paper without tripping over yourself. And believe it or not, it's a lot easier than it sounds. I apologize, I forgot to change the date. 2018, I just hit print and probably with it. So it's not like these have changed all that much. So on here, on this first part, you'll notice that you've got algebraic properties of what's called equality. And again, these are properties that all of you guys have been using forever. Because you guys, whenever you're solving an equation, you had to use a property to move a number. Remember how when you solve equations, you got to keep things balanced? You got to keep things equal on both sides? That's where this stuff comes from. So if I start with a very, very simple thing. Let's say I want to take an equation, 2x minus 1 equals 7. And I'm going to solve it. But I'm going to solve it by writing down why I'm doing each step. Okay? Now, most of us could probably look at this and kind of go through and say, oh, I can get this done in one step, 2 steps, and be done with it. Okay. But here's the thing. When you're doing proof stuff, you can't skip things. You have, I know, it has to be very, very literal. I know, but remember, the math part of this is the easy stuff. It's can you put that string of thought down that it is sequential, following step by step. So, sorry. When you start with proofs, you're going to be given something to start with. For example, here I gave you guys an equation. So my first step was to, what are we doing? Well, we're going to solve this equation. So step number 1 is I'm going to solve that equation. Why did I write that down? Well, I was given it to do. First step is usually going to be always writing down what you are given. As we get going into geometry stuff, you might have more than one given. That's for later. Right now, I'm giving you an algebra equation. So, why'd you write it down? Because Mr. Murphy gave it to me. You're given. Now, we all know what our next step would be to do what? Add what? Okay, so what are you doing? My second step, what am I doing? I'm adding 1 to both sides. So what property tells you that you can add 1 to both sides? Well, algebraically, what did I just add? I used the addition property, didn't I? Yeah. Now, here's the thing. Did I do that over an equal sign? Did I add to both sides of an equal sign? Yes. So did I add over an equal sign? Yeah, that's what that phrase means. So what happens here is I added to both sides of the equal sign. So my reason, add property of equal. I added to both sides of the equation. I kept it balanced. So what I'd like you to do, as we go through some of these reasons here, I want you guys to, whatever I abbreviate as, you're legal to abbreviate it just the same. I don't want you making up any of your own abbreviations. I don't know what they mean. But if you write add prop equal, I know that's how I would abbreviate addition, property, and equality. Too many words. Add prop equal. So any abbreviation, put it on this list, because I'll let you have this list. This is a legal list to have. Okay? After you do that, what's your next step? Say that again. Perfect. I simplify it. I simplify this by, well, I get 2x equals what? 8. Every time you go through a step, after you add both sides, you simplify. Okay? What do you do next? Divide both sides by 2. Am I dividing on both sides of an equal sign? Okay. So I show it. I'm dividing both sides by 2, which means I use the division property of equal. Everybody okay with that symbol for division? You don't have to add the word for that, guys. I'm okay with it. Okay? Yes, ma'am. No. Oh, there's no abbreviation for proof. It's just a proof is how do you show that something occurred? By what means do you show that it works? And then lastly, what do I get now? 4. What is 4? Perfect. Now, in the previous step, when we did the math, we wrote simplify. Here, I had nothing left to do, so what is it? What did we do to the equation? We solved it. We solved it. Yes, it's 4. I wrote down a 5, and I thought I was writing the 5 here for step 5. You're right. 8 divided by 2 is 4. And you're done. I know that you were saying that you don't want to have to write all the words, but it's the idea. Once you get the idea of breaking it down step by step by step, once you get through this stuff, the rest of it is so much easier because you understand sequencing. You understand that you can't skip things. By always starting with the algebra stuff like this, guys, it slows your brain down. Okay? You have to believe me that there's a reason why I do this stuff. I know it's hard to believe, but there are reasons in my head that I have good ideas. Sometimes. What's that? What do you mean? Like the idea of a proof? Well, when you start getting into the idea of proof, start thinking about exploration. Some people explore and they just go west, trying to figure out what's out there. Some people build rockets and they go into space, try to figure out what's out there. Some people have to figure out why do certain things work mathematically, and they go into it and they start putting together the properties. So over the course of hundreds and hundreds of years, mathematicians have been doing this idea of what's this all mean? Why does this stuff work? And that's where proof comes in, because everything that we've done, there's some sort of a property to them, and this is just putting it all in paper. Okay? So there's been years and years of things, and I'll show you guys some of the proofs that I had to do in college. I don't even remember how to read them, but whatever. Yes, ma'am.
I have a question. It is a really math, but it's kind of what you were just saying. Okay. No, it's really not. Okay. So there's something in the middle of like nowhere, it does like all the way down. But they reach the core.
The core of the earth?
Yeah. Is that possible? Like they have like those little drill things.
Yes,
that people
drills.
can go inside. No.
How much that hurt?
Does it have an actual base?
The drill bit?
People can go inside of it, right? No, like what are those things?
Oh, capsule?
Yeah.
You could, but if you start to if you really see, there's some I saw an infographic once that talked about the depths of the oceans, how deep certain parts of the oceans are and stuff, and how far people have actually drilled. We're not even at the depths of some oceans yet. You have to realize how big the Earth really is. And if you think about just going 10 miles, it seems like it, but 10 miles doesn't get you halfway through the Earth. You know, that'd be awesome. Okay, that'd be awesome. All right, let's try another one. Let's try another one here, guys. I am no longer writing out the words statements and reasons. I'm going to put. So, excuse me. As I had said earlier, or as we were saying earlier with a lot of this stuff, it goes back to writing out equations using properties to solve them, and it works rather quick. Where's the one I want? Sometimes you get to the algebra. Well, you have to understand the algebra to be able to do stuff. Let's look at this one. Let's say you have 2 times the quantity x minus 1 plus 4 equals 11. No, 10. We'll do 10. Make it easier. Why did I write that problem down? Okay. Oh yeah, probably tomorrow because I'm out of time right now. What are you gonna do first? Would you be wrong if you did that? Correct. Now, I wanted to show this one out that there's actually 2 different ways that you can start the problem. One of the ways you could have started the problem is you could have moved the 4. How would you have moved the 4? By subtraction. Now, another thing that most of you guys had stated for starting the problem was to do what? To distribute. Now, within proofs, a lot of times there are specific steps that you would do first, especially in terms of geometry. But as we know with algebra, you can do a couple of different things. You should still wind up at the same spot. You should still get the same ideas. The properties are all going to be used, but we might just use them in a different sequence. Okay. Yes, Kate?
Okay, so in this case, would you do peg
I would do the SAT map is normally what I would have done, but this would be the idea that sometimes people see that they know they have to distribute, they do that first. Otherwise, if we do the SAT map, which is ways we've been doing for our solving, I would move my 4 first. So I'm just going to move my 4 first and follow that same pattern of SAT map. So my second step would be I would subtract 4. What is the reason that I subtracted 4? What reason do you think that would be? Of? Oh. We move it up. Remember, when we go an equal sign, it's always of equal. So, subtractions, SUBTR, because I don't want to use just sub, because that could be substitution. All right, let's do that. Let's use a minus sign. That works. In years past, I haven't, but for you, I'll make an exception. Parallel probably would be sideways. What's my third step? Simplify. I get my 2 times the quantity x minus 1 equals 6, and we simplify. Okay. Now what am I going to do? Distribute. Good. So if I distribute out my 2, on the sheet, there's actually distributed property. It's the, what is it, the fifth one down on the top. What do you think the easiest way to, did I distribute things to both sides of an equal sign? So is it ever going to be distributed property of equality? No. So here's what I write out for distributed property. This is a good abbreviation. Distro property. Very simple. Distro property. Now what? Add. I'm going to add the two to both sides. Very good. And again, guys, you have to show your steps. You can't skip them. What was our abbreviation? Was add prop equal? I thought I wrote add before. I'll survive. There's our add prop equal. What did I do there? Very good, very good. Is it okay to have the same reason multiple times? Yes. It is. There are no set number of steps for any of these that you can wind up with. It's just a matter of working it through. And then lastly, what do we have? We have to divide first. We have to show it. That's the thing. It'll kick. I mean, you guys know how to do the math. You guys know how to do the math, but it's the idea that you can't get ahead of yourself. You have to say what you're doing before you do it. And you gotta say what you're doing before you do it. And then what was our answer? Sure, it's not 5. Excuse me. That's what these are going to look like. Right? That's what these things are going to look like. They're very straight. Excuse me. Yeah, give you guys a few. All right. Let's see. Okay. Hey, ladies and gentlemen, I'm just going to give you guys that one. And no, because the algebra ones they have in here are a little bit different than what we've done. So we'll do more of the algebra ones tomorrow. I just wanted to get this started. All right. So those are your guys. Those are your detachment and syllogism. It was basically saying, telling you. Because I taught it once or twice. So the first one says, if possible, use the law of detachment to make a conclusion. If it's not possible to make a conclusion, tell why. So, if a doctor suspects her patient has a broken bone, then she should take an X-ray. Dr. Dimba suspects Lily has a broken arm. What's your conclusion? Done. Go to the next problem. That's kind of the idea here, guys. Right? It's fairly